A very good morning to everyone, especially to our lecturer, Madam Anisa LUQMAN. So basically today, me and my groupmates would like to present to all of you about our design project. My name is HARULNIZAM. My registration number is 01DK30F2009. My groupmates are consisting of FAIZZUDIN, HAZIQ, and SYABIHA. All of us are from DK4A. So without further ado, let's get into the design project. In this slide, I'm going to talk about the beam B12. For the GK, we have 0.7 kN per meter square and QK 0.6 kN per meter square. The Ly over Lx is equals to 1. So that means it is a two-way spanning according to this picture right here. Okay, for the first step, right here we have to find the loading analysis. The design action is 1.85 kN. The total action for B12 is 21.31 kN. The Mmax, we have the formula of WL over 6 equals to 17.05 kN, and Vmax, we use the formula W over 2 equals to 10.66 kN. Next, we have to determine the trial section. For our design project, we assume the beam is S275. So the section is 203 times 102 times 23 universal beam. So that means the plastic modulus should be 234 cm3. And the next step, which is the third one, we have to classify which class of the flange and the web. So flange subjected to compression, the formula is C over T less than 9 epsilon. The CF over DF equals to 4.37 is lesser than the 9 epsilon, which is 8.28. So that means the flange is in class 1. Next, web subjected to bending. The formula is C over T less than 72 epsilon. CW over TW equals to 31.4 is less than 72 epsilon, which is 66.24. So that means web is also in class 1. In this slide, we're going to have a look at the fourth, fifth, and sixth step. For the fourth step is the shear resistance. We need to satisfy the VED must be lesser than VCRD. The VED that we got from the previous step is 10.66 kN. AV is equal to 1238.1 mm square, and NHWTW equals to 996.84 mm square. So that means AV is smaller than NHWTW. So for VCRD is the same as VPLRD and is equal to 196.57 kN. So that means VED is smaller than VCRD and it's okay. For shear buckling for web, we need to satisfy this formula, which is HW over TW is lesser than 72 epsilon over N. The HW over TW is 34.19 and the other one, which is 72 epsilon over N, is 66.24. The HW over TW is smaller than 72 epsilon over N. So that means it's okay and the checker is not required. For the sixth step, we have the bending moment resistance. We must satisfy the formula that is MAD is lesser than MCRD. The MAD is 17.05 kN and MCRD is 64.35 kN. So that means MAD is smaller than MCRD. So that means it is okay. In this slide, we're going to have a look at the step 7 and 8. For step 7, we have the combat bending and shear resistance. For this step, we have the picture right here for reference. So basically, from the picture, we can see that VED at Mmax is actually 0 kN. Next, we have to do a little bit of calculation, which is the 0.5 times with VCRD. Then we got 98.29 kN. So from the calculation, we can conclude that VED at Mmax is 0 is lesser than 0.5 times VCRD, which is 98.29 kN. So from that, we can do the conclusion that VED is small and it does not affect the moment resistance. For vertical deflection, we have to satisfy this formula, that is delta max is lesser than delta allowable. For delta max, we have 0.000602 mm, and for delta allowable, we have 24 mm. So that means the delta max is actually smaller than the allowable one, so it is okay. Now that I finished with my presentation part, so now I'll pass to NURUL SYABIHA to continue with the caller presentation. Thank you so much for listening to me.
Thank you, Luqman. Hi, Assalamualaikum. My name is NURUL SYABIHA binti HAMDAN. My matric number is 01DKA20F2017. Now, I will continue this presentation about column. For load analysis, set weight of column 1 is 1.21 kN. Total compression force in NAD is 22.52 kN. For classification of section, flange is subjected to compression, where we get 8.28. Flange is in class 1. For web is subjected to compression, where we get 34.96. Web is in class 2, so overall of classification of section is in class 2. For collar slenderness, LCR is 1.0L. LCR for YY section is 4,800 mm, same goes with LCR ZZ section. For lambda YY section is 0.66, while lambda ZZ section is 2.35. For compression resistance checking, NED is 22.53 kN, NCRD is 898.5 kN. Overall, compression resistance checking is okay because NED is less than NCRD. Buckley resistance checking for YY axis NBYRD is 695.31 kN. NED is less than NBYRD, so it's okay. For ZZ axis, NBZRD is 129.36 kN. NED is less than NBYRD, so it's okay. For lateral torsional buckling, MCR is 103,681.0108 kN. MBRD is 4,697.5 kN. Bending moment resistance at ZZ axis, MZRD is 13667.5 kN. That's all from me. Now I will pass this presentation to HAZIQ. Thank you.
Hi, Assalamualaikum. My name is HAZIQ and my matric number is 01DKA20F2013. Now I'm going to continue with the presentation with micro trusses. As you can see, this is the picture of various trusses and has been calculated, and its NED is 5.16 kN and NED in compression is 7.75 kN. And we choose section 100 times by 75 times by 10. Next, I will show you the calculation. First, we check the design of the tension member. NED is smaller than NTRD, and BRD is equal to 456.5 kN, ANET equal to A minus AO. AO is 220 mm square, and ANET is 1440 mm square. For the NURD is 445.82 kN. So the conclusion is NED equal to 5.16 is smaller than NURD is 445.82. So that's okay. Next, we move on to NED is smaller than NCRD. So the conclusion show the NCRD is 456.5 kN. So the conclusion is NED equal to 5.16 is smaller than NCRD equal to 456.5 kN, and that's okay too. And next we move to design of the compression member. So NED is 1 over cell of NBRD. So NCR is 19.978 meter, but the lambda is 1.95. Next is 2.70, and for the pair is 2.22, and it's smaller than 1.1, so that's okay. And the NBRD is 100.45 kN. So the conclusion is NED equal to 7.75 kN is smaller than NBRD equal to 100.45 kN, and that's okay. That's all from me. Thank you.
Hi, my name is FAIZZUDIN. My registration number is F1013. So today I will continue this presentation about check the design resistance of voltage connection in figure 3. This is diagram about splice plate. Grade of splash plate is S275. Grade of bolt is 8.8 and diameter of bolt is 20 mm. Okay, after that, we find a shear resistance per bolt FVRD. FVRD formula is AV times FUB times AS over gamma M2. FUB is 800, AV is 0.6, AS to 445, gamma N2 is 1.25, FYB is 640. So FVRD is 94.08 kN. Next, bearing resistance per bolt FBRD. FBRD formula is K1 times AB times FU times D times T over gamma M2. Fy is 275 Newton per millimeter square. Fu is 430 Newton per millimeter square. Diameter is 20 millimeter and T is 10 millimeters. AB is smallest of AD. AD for end bolt is 0.76. AD for inner bolt is 0.85. FUB over FU is 1.86. For each bolt and for inner bolt, K1 is 2.5, FBRD is 130.72 kN. After that, we find a tensile resistance of cover plate. ANET, formula ANET is area minus area of bolt. So ANET is 3680 mm per square. So NURD formula is 0.9 FU times ANET over gamma N2. NURD we got 1139.328 kN. The last one we find a tensile resistance for bolt FTRD. The formula is K2 times FUB times AS over gamma N2. So FTRD is 141 and 141.22 kN. Okay, that's all from me. Thank you.
Next, I will continue with design output drawing. And this is the house that we built using SketchUp. And this is front elevation. The bottom one is left elevation. Next is floor plan, and roof plan view. Next, this is our beam. The section that we use is 203 times by 102 times by 23 universal beam. And this is the measurement according to Euro code. And the middle one is 1.4 mm in thickness, and thickness at the top is 1.3 millimeters. And the bottom one length is 101.8 millimeters, and the left one height 203.2 mm, and the left one is 169.4 mm. Next, this is our roof truss, and the right one is our column. And this is our bolted connection that have been drawn in SketchUp. That's all from us. Thank you for listening.